So now, what about the possibility of multiple solutions? So this is my next topic of non-degeneracy. Let's suppose we have just two generic solutions. Suppose we have, now secretly they might just be related by a constant, but I'm just imagining, I'm not going to make any assumptions. Suppose we have two solutions, and these are bound states, so I want to be very clear about this. Two bound state solutions, right, of the same energy, right, of energy, say, En. And I'm going to call these solutions phi sub n A of x and phi sub n B of x. Now, the first thing that we know is if these are some arbitrary complex solutions, we know they are both related by constants to real solutions. These must be, that's what we just proved, these must be related by constants to real solutions. So we could, for example, identify phi n A of x as some complex number, I'll call it ZA, potentially complex, hopefully it's not complex, times a nice real solution, phi A of x. And of course, the other solution, I can also, as we've just been saying, know that it would be related by a constant to some other, potentially other real solution. So my entire question then really boils down to how are phi A and phi B related? Are they necessarily related by a constant? So that's our question. Is, I guess we could say, is phi A of x equal to just some constant, I'll call it capital C, times phi B of x? Well, to answer this, we can consider the following. Let's consider a new wave function that I'm going to make. So I'm going to make this function phi of x, and I'm going to construct it as a linear combination of these two potentially different, but we will see, real solutions that I've been handed. And I will construct it in this form. Now, because the time-independent Schrodinger equation is linear, because I know phi A is a real bound state solution of energy En, and phi B is a real bound state solution, again, of exactly that same energy E sub n. We're all talking about solutions of energy E sub n. I know that any linear combination of them, because the equation is linear, is also a solution, a bound state solution of energy En. So I may as well call it phi sub n. And then what I'd like you to notice is that this is exactly the mathematical form that I began with for my previous proof. It was where was he? Here he was, right? I said, let's suppose I have a bound state in this form. And that's just exactly what I'm looking at again now. And so I can run the entire proof through again. All of these facts will continue to apply. I will get this current density. I will conclude this differential equation. I can solve it, and I will find right there that those two, phi B and phi A, are indeed related by a constant. Consider that. From the above, we know that, in fact, phi A of x will equal, we had called it e to the c times phi B of x, but e to the c then is just this overall normalization constant. So I've proved, just to summarize, that if I have any two real solutions to the Schrodinger equation of the same energy, that they are in fact related by a constant. And previously I had proved that if I have any two even complex solutions, they can be related to those two real solutions, which also then must be related to each other by a constant. So Everybody is related to each other by a constant. There is, in fact, for any given energy En, at least in one dimension, there is only one solution.